So for today, I gave some homework so we could practice seeing angle relationships. So I want to walk us through a few of the angles on here. So what this actually looks like on the worksheet is sort of like a Donkey Kong player board. What we're doing is we're calculating and trying to figure out what some of these angles are. So there are, let's see, 26, 27, 28, 29, 30, 31 different angles. Quite a few of them are the same. We just got to recognize it. So what we talked about in class was that if we have 35 degrees here and C here, right? This is on a straight line, so there should be 180 degrees along there. So we could calculate C by taking 180 degrees and subtracting 35 of them, which should give us C right there. All right, you can do that same thing for this. You can do that for this. Now you wouldn't use 35, but for this one you'd use 110. This one you'd use 125. This one you'd use 130. I think you get the picture, right? All right. Next part. So say, for example, we get D here. So once we get D, we should have 180 minus 110 is 70. So 70 degrees. So we have a straight line here, right? So if this is a straight line using vertical angles, right, we know that K and D are going to be congruent. So this is also going to be 70 degrees. And we know that these two are vertical angles, 110 and L. So this is going to be 110 degrees. All right. We could also see the same thing occur right here. So if we see 132, now another thing is we can assume that all these horizontal lines are parallel. So this one and this one are parallel. So 132 and A, if we look at the two of these, we will find that A should be 180 minus 132, leaving us with 48. All right, so it's going to be 48 degrees. All right, and if we look at this, so if this is a parallel line right here, A and Y are going to be congruent, and this 132 and Z are going to be congruent. So if we put a dot right here, the midpoint between the two, if we were to then rotate about that point to get from A to Y, we would see that they're congruent. So as we do that, we'll see that this is 48, and this is 132. And then from there, this right here is 180 degrees. So if that's 180 degrees, then W is going to be, W and Y will be the sum of 180 together. So subtract 48 is just like this. W will be 132. X right here, that will be congruent to angle Y. Those will have vertical angles. Those have a vertical angle relationship. And then if we even keep going up here, right, it's still the same line. So we should have similar relationships. So if we saw 132 here, we're going to see 132 there as corresponding angles. And Y and U are also going to be corresponding angles. And a reminder, this kind of thing is very useful in architecture, very useful in engineering, being able to understand a lot of different physics where you have to draw free body diagrams. Understanding these things is super useful. There's a lot of forces you can only understand once you've calculated their angles and their relationships. All right, so we have a lot of supplementary angles. We have this example here, which would go along with this, and with this one. So the last one I'm going to talk about here are some triangles we see, right? So we see a triangle here, see a triangle here, see a triangle here. So I'm going to take a look at this one, right? So if you look at P, Q, and R, right, all three of those are going to add up to 180 degrees. So if that's the case, what could we figure out first? Well, we have a line here and a line here. We have a number associated with it here, number associated with this here. 180 degrees are inside of a triangle, right? So there, 23 plus 68 plus Q should be 180. So if you take 180, subtract 23 and 68, should end up with, let's see, 91, so it should be 89 degrees. So if that's 89 degrees, P and R should add up to 91. And if we notice this is going to be the same as this, as alternate interior angle relationship. Same thing here, 68 and R, that's also going to be the alternate interior angle relationship. So that solves for PQR, and given what I've just told you, you can apply the same thing over here to here. You can apply this over here to there. I don't think there's anything else that you should need besides those angle relationships, as long as you apply them correctly. I look forward to seeing us do our homework and staying weird.